student, welcome to all of you. Next physics lecture. This is the video number 35. Now we have to see here the chapter number 5, oscillation, and the next point in that chapter is very important, composition of 2SHM. This composition of 2SHM we can find out by the analytical treatment where mathematically, so that we have to consider here the 2SHM having the same period, same path, but different amplitude and different initial phases, and which can be represented as, by using the formula for the displacement, x is equal to a sin omega t plus alpha. Instead of phi, you can use here alpha. Okay. For composition of SHM, we have to consider here 2SHM having the same period and same path, but different amplitude and different initial phases. Then these two displacements are represented as follows, and which are nothing but x1 is equal to a1 sin omega t plus alpha 1 and x2 is equal to a2 sin of omega t plus alpha 2. See here, same period and same path along the x-axis, same path and same period tt. Okay, then different amplitude, here a1, here a2, and initial phases, here alpha 1, alpha 2. That means amplitude and initial phases are different but same path and same period we have to see in this two displacement. You have to understand this well. Consider the two SHM having the same period and same path but different amplitude and different initial phases, and we have to write here x1 is equal to a1 sin omega t plus alpha 1 and x2 is equal to a2 sin omega t plus alpha 2. We have to find here the resultant displacement, and which is nothing but x is equal to sum of these two displacement, x is equal to x1 plus x2, and substituting this value, x is equal to a1 sin omega t plus alpha 1 plus a2 sin omega t plus alpha 2. By using the trigonometric relation, we have to use the laws in this sin omega t and cos alpha 1. We have to use this. Then the x is equal to a1 into bracket sin omega t cos alpha 1 plus cos omega t sin alpha 1. Same way, plus a2 as it is, and by using the trigonometric relation, sin omega t cos alpha 2 plus cos omega t sin alpha 2. You have to remember that sin cos cos sin cos cos sin. By using these rules we can write. Then we can take the common sin omega t, and here we have to take in the next terms cos omega t, and we can write this separately. See here, x is equal to a1 cos alpha 1 plus a2 cos alpha 2. Right here, a1 cos alpha 1 plus a2 cos alpha 2, and common term sin omega t is here. Okay. Similarly, a1 sin alpha 1 plus a2 sin alpha 2, and constant term cos omega t. Again here, a sin alpha 1 plus a2 sin alpha 2, and cos omega t is a constant. Okay, then these bracket terms, instead of these bracket terms, let we put the cos bracket r cos del, sin bracket r sin del. We have to substituting here, therefore we have to write here, let put a1 cos alpha 1 plus a2 cos alpha 2 is equal to r cos del. This is suppose equation number 1. And second bracket, a1 sin alpha 1 plus a2 sin alpha 2 is equal to r sin del. This is the equation number 2. You can use the tricks here. Cos bracket r cos del, sin bracket r sin del. You have to remember this by using these tricks, r cos del and r sin del. Then substituting this, instead of this a1 cos alpha 1 plus a2 cos alpha 2 r cos del into sin omega t right here, plus second bracket a1 sin alpha 1 plus a2 sin alpha 2, instead of this we can write r sin del, here r sin del, and into bracket into this common factor, this is the cos omega t. Again, we have to rearrange these terms and we can write x is equal to, r is the common on both terms, r, into bracket we have to write here sin omega t cos del plus cos omega t sin del. Again, sin, cos, sin, and this is nothing but x is equal to r sin omega t plus del, and this equation is known as the resultant motion in SHM. X is equal to r sin omega t plus del. This is the composition of SHM. How we can these two displacement can be the composed in single one, and shows that the resultant motion in SHM, that is the x is equal to r into sin omega t plus del. Okay, now we have to see here how we can to find out the resultant amplitude and the initial phase. Initial phase, it should cannot be find out in your exam or in numerical, but the resultant amplitude you must be find, and so that the resultant amplitude in SHM can be find out by the squaring and adding the equation 1 and 2. We have to find out the resultant amplitude in SHM, and for that purpose we can squaring and adding these two equation 1 and 2, and solve this in shortly. We get here r square, LHS terms see here, r square cos square del plus r square sin square del, but you know that well cos square del plus sin square del is equal to 1, and therefore simply is r square. By squaring on this RHS, r square cos square del plus r square sin square del, r square is common, and sin square del plus cos square del we can write 1 by using this formula, and here simply this RHS is we can write directly r square. Okay, then we have to see here the a1 cos alpha 1 plus a2 cos alpha 2 bracket square plus a1 sin alpha 1 plus a2 sin alpha 2 bracket square. We have to solve here this bracket terms. You know that this expand a plus b is equal to a square plus b square plus twice ab. Same way, r square is equal to a1 square cos square alpha 1 plus a2 square cos square alpha 2, and middle terms we have to write here twice a1 a2 cos alpha 1 cos alpha 2. Similarly, second term, the a1 square sin square alpha 1 plus a2 square sin square alpha 2, and middle term twice a1 a2 sin alpha 1 sin alpha 2. Okay, then concentrate here, a1 square is common, in bracket you can write sin square alpha 1 plus cos square alpha 1, and we know that this formula well, sin square theta plus cos square theta is equal to 1, therefore remaining term should be a1 square. Similarly, a2 square is common, in bracket cos square alpha 2 plus sin square alpha 2, and value of this equal to 1, and remaining term is simply a2 square. Then last one, twice a1 a2, it should be common, twice a1 a2, and bracket terms is cos alpha 1 cos alpha 2 plus sin alpha 1 sin alpha 2, and this is the formula for sin of alpha 1 minus alpha 2, and therefore the resultant amplitude r square is equal to a1 square plus a2 square plus twice a1 a2 into sin of alpha 1 minus alpha 2. The resultant amplitude r square is equal to a1 square plus a2 square plus twice a1 a2 into sin of alpha 1 minus alpha 2. Taking the square root, we can also write these terms in such a way that r is equal to into square root a1 square plus a2 square plus twice a1 a2 sin of alpha 1 minus alpha 2. Okay, now also we can find out the initial phase by taking the ratio of equation 2 and 1, because first is cos and second one is sine. We have to taken the sine upon cos, and for that purpose we have to taking the ratio of equation 2 and 1 to find out the initial phase. The initial phase can be find out, we can write directly here, the sine upon cos is nothing but the tan del, r cancelled, and simply a1 sin alpha 1 upon a1 sin alpha 1 plus a2 sin alpha 2 upon a1 cos alpha 1 plus a2 cos alpha 2, and last term we have to see here, not right, but you can write the del is equal to tan inverse of, tan take this side, then del is equal to tan inverse of same bracket, that is the a1 sin alpha 1 plus a2 sin alpha 2 upon a1 cos alpha 1 plus a2 cos alpha 2. Now there are the three special cases. If the phase difference between two SHM is equal to 0, the phase difference between these two SHM, that is alpha 1 minus alpha 2, is equal to 0. Substituting this value, this in resultant amplitude, this r square is equal to a1 square plus a2 square plus twice a1 a2, and instead of alpha 1 minus alpha 2, we can write 0. Then we know that the cos 0 is equal to 1, and substituting this value, r square is equal to a1 square plus a2 square plus twice a1 a2, and we take the square root on the both side, then the r square is equal to a1 plus a2 bracket square, or r is equal to a1 plus a2 simply. Okay. Now second case is the phase difference between the two SHM, that is the alpha 1 minus alpha 2 is equal to pi. And also we know that the cos pi, value of the cos pi is nothing but what? Minus 1. And then we have to substitute this resultant amplitude, r square is equal to a1 square plus a2 square plus twice a1 a2 cos of alpha 1 minus alpha 2. Instead of this we can write cos pi, and then cos pi is equal to minus 1. Then we get r square is equal to a1 square plus a2 square minus twice a1 a2, and this is the square of what? a1 minus a2 bracket square. Then taking the square root, we can write r is equal to simply a1 minus a2. And last one case is the phase difference between the two SHM is equal to pi by 2. That is the alpha 1 minus alpha 2. The phase difference is equal to pi by 2. Then we know that the cos pi by 2 is equal to 0. Then substituting this value, r square is equal to a1 square plus a2 square plus twice a1 a2 into cos of, instead of alpha 1 minus alpha 2, we can